about that. Okay, I think I said this to you on day one, but we split our chapters in half, which is really lovely because then we get to just do half a chapter, take a test over less material, then do the other half of the chapter, take a test over that material. So hopefully that's a beautiful thing. So we're calling this chapter 5A. We're starting with 5.1. I think Mr. Lever said you maybe started doing some of this at the end of the school year with him last year. We try to do it again just to make sure we've got it and know what it all is, and then it feels like a little bit of review. So we're going to be talking in this first chapter, half a chapter, about systems. Do you remember what a system of equations is? It's a number of equations. How many equations would make a system of equations? 2 or more. Okay, so if you have at least 2 equations that are related to each other somehow, that's called a system of equations. So 2 or more equations with the same variables. Okay, I would say most of the time with what we're going to do, those variables, any guesses if there were 2 variables to pick, what 2 variables show up the most? Which 2 letters? X and Y, okay? So I'd say most of the time you're going to be dealing with X's and Y's in systems like this. That's what you'll see mostly today. So graphically, if you're looking at it on a graph, a solution to a system would be where those 2 lines intersect or where they meet up. Okay, so we're looking for an intersection. You've definitely seen a graph like this before, I'm sure, where you don't have to write this down. I'm just going to show you. If this is one of my systems, okay, that's the graph of one line, and then the graph of another line goes right here, then my answer is that point. So the point where they meet, that's the solution that we're looking for. So today what we're going to do is we're going to be graphing, and you're going to be doing a graph of one line, a graph of another line, and telling me, okay, well, that means my answer is the point 1, 2. Okay? So just remember, you're trying to give me a point as an answer most of the time. If it is algebraically, so if we're going to be solving the system using substitution or elimination, do you recognize those words? Did you do substitution or elimination last year with Mr. Lever? Maybe, yeah. If we're doing it that way, then that point makes both equations true. Okay, so if the equations are both true when you plug in that X and Y value, that's a solution to your system. Okay? Okay, different types of solutions. The first one is you could have a solution that is intersecting lines. So intersecting, what is an intersection? Two lines, they meet. An intersection is where 2 lines meet. If you think, how many of you drive? Anybody drive? Maybe not quite yet, a couple of you. An intersection is where these 2 roads meet up, right? That's an intersection. We're looking for that intersection, that point where they meet up. So an intersecting line setup would be this. You have one solution there, and it is this point right here. So your one solution would be some point, some X value and some Y value. Okay, but then you have a situation where they don't meet. They're parallel lines. So parallel lines could look like this. Okay, those would be parallel lines. How many points of intersection do parallel lines have? 0, which means you have no solutions. And no solution, we often write like that. Okay, it's a 0 with a line through it, means no solution. Other times, you're going to have 2 lines, and they're actually, so 2 different equations, but they are the exact same line. So I'll have a line here, and then I'll have a line here, okay, and they match up perfectly. How many points of intersection do you have there? An infinite amount. You have infinitely many solutions. Anyone know the symbol for infinity? It's the sideways 8, right? It's the infinite loop. something like that. So you may write infinitely many solutions, or you may write the symbol for infinity. Or you may write no solution, or you can write the symbol for no solution, okay? If it is one solution, I want which one solution it is. I want that as a point. So tell me the X and the Y for that. But if it's one of these two options, you may either write the word or the symbol, okay? Questions on that? Okay, so here's what we're gonna do. We are gonna solve these systems by graphing the lines. And there are 3 steps that we're gonna follow to make sure that we are doing that the correct way. Step number 1 is, if needed, this one's not always necessary, but if we need to, we're gonna rewrite the equations in a certain form. Do you know which form is usually the easiest to graph? Which form of an equation? Standard could be arguably an easy one to graph. I would say it's not the most common one to graph. Do you know another form? There's standard form, there's point slope form, and there's slope intercept form. There's slope intercept form. So we're gonna rewrite them in slope intercept form. Sorry, I'm writing too big here. So rewrite them in slope intercept form first. But like if you look down here, okay, number 1, those are both in slope intercept form. Remember, slope intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. So that's step 1. Rewrite them in that form. Step 2 is we're gonna graph the lines. Graph both lines. And then the final step, which is usually the one that gets forgotten, because once you graph, you see the answer, but then you forget to tell me the answer. So the last one is identify the solution or solutions, okay, which just means give me the point. So what point, what X and Y did you land at? Any questions on that? Okay, then all we're gonna do today is figure out how to do those 3 steps. We're gonna walk through that and see how it goes and see what we've got, and go from there. So you don't need to take notes necessarily on this right now unless you would like to take notes on this part right now, but I just wanna make sure that the form that we're working with is well understood. Maybe you wanna write this part down somewhere where you can find a little gap in your margin or something. Or you can do it you could do it up here if you want. Y equals mx plus b. M stands for what? Slope. Okay, so when we're talking slope, can you tell me another, like a phrase that makes you think slope? Think of it like a fraction. Were you gonna give me something? What? Y over x, yep. It's the change in y over the change in x, or they both start with r. No. It's the rise and run. It's the rise over the run, okay? So your slope is gonna tell you how far up or down did you move. If it's positive, it's going up. If it's negative, it's going down. But then your run is how far did you go to the right. Okay, so we always go up or down, and then we always go to the right. Rise over run. Good on that? Okay, what does the B represent? Do you remember? That's the y-intercept. Y-intercept. Okay, can someone tell me what a y-intercept is? What does that mean? It is your starting point. the y-intercept is not the line itself, but it is on a line. It's on the what? The y what? Axis. It's the point on your y-axis. It's where it hits your y-axis. The y-axis is which axis? This one or this one? It's the vertical, okay? So this is your y-axis. You can see it in the graph there. So we're looking for where does it hit that? Where does it hit the y? Okay, so here's what I'm going to do. I'm going to pick two colors. Do you want to pick two colors so you can match me if you're doing color coding? Pick a color. Purple. Okay, so one of my lines is going to be purple. We'll do the bottom one. What do you want the other one to be? Pink? Well, we're going real girly here. Okay, so one's purple, one's pink. Okay, I'm going to start with the pink one. If I'm trying to graph y equals x minus 8. Jason, are you with me right now? Yeah? Okay, because I haven't seen your eyeballs for a while, so just making sure you're here. Where do I move first if I want to graph this? What? On the y. How far? 8. In which direction? Negative. You're going to go down, right? If it's a negative 8, you're going down 8. Okay, so on my y-axis, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and I'm going to plot that point. Okay, so that's step 1 of graphing your first line. What's step 2 of graphing that line? We found our y-intercept and we plotted it. What's the other point of slope-intercept form? There's the y-intercept and the slope, right? There's the slope. It's your m value. So once you do the b, okay, so you do your b first, and then you do your m second. You do your slope second, okay? What is the slope of this line? It's 1. If there's nothing in front of the variable, it's a 1, okay? Now, it's easiest if you always think of slope as a fraction. So what is 1 as a fraction? 1 over 1. Okay, so if my slope is 1 over 1, then that's rise over run. So I'm going to rise 1, and I'm going to run 1. So I'm going to go up 1 and over 1. So go back to your 8 here and go up 1, right 1. Up 1, right 1, up 1, right 1. I am maybe heavy on the number of points that I like to plot just because I really like straight lines. So I usually plot a bunch of points. How many points do you have to plot to be able to draw a line? 3 would be great. 2 is all you really need. But I think especially if the slope is 1, do a few, okay? So your slope looks... And I'm not in Notability, so mine won't be straight. But you can make yours straight if you're in Notability. So that's the first line. Okay, now let's apply that same idea to the second line. So now you have y equals negative 2x plus 1. What do you plot first? Your m or your b? Your b. Okay, my b right now is what number? A positive 1. So if it's a positive 1, where do we move? Up 1. Okay, so that's here. What is my m? M is not negative 2x. I'm so glad you said that, though. A lot of times when I ask people, what's the slope of this line? They tell me negative 2x. The slope is the m, not the mx, right? So my slope is actually what? Negative 2, okay? So if my slope is negative 2, I'm going to treat that like negative 2 over 1 because we want it to be a fraction because we want to rise and we want to run, okay? So if I'm going to do negative 2 over 1, I'm going to go down 2 to the right 1, down 2 to the right 1, and look what happens. If you keep going down 2 to the right 1, we hit our other line. What does that point mean? It's your solution. It's your answer, okay? So draw that line in. And then your solution is however you name that point. Now, A lot of people mix up the x and the y. Take a minute and look at that point and tell me what the name of that point would be. But as a point, tell me what numbers go here and here. Do you know? Is it 4? 1, 2, 3. So on the x, you're going 3 to the right. So that's a positive 3. On the y, you're going 5 down. That's a negative 5. So your solution is the point 3, negative 5. Do you know how you can check your answer? Into what? Yeah, so you have two equations, right? If you plug 3 in for x, you should get what for y? What's your solution? 3, negative 5. So if I plug 3 in for x, it should equal negative 5 when I'm done. Let me show you. So if I go like this, from this equation, y equals 3 minus 8. So y is negative 5. When I plugged in 3, I got negative 5. That is the point, 3, negative 5. So it worked, okay? It should work for both of them. So if you do it here, y equals negative 2 times 3 plus 1. That's negative 6 plus 1 is negative 5. So it worked for both of them. That's how you know you got the right solution. Do I need you to check your solution every single time? No. But if you're like, I don't know if I did it right, this is what you should do. If you're like, I think I did something wrong, or it doesn't seem to be matching up, plug your number in and see if you get 3, negative 5 as your answer. Okay? Questions on that? Okay. I want you, using those principles, so this is your M, this is your B, this is your M, this is your B, try to graph those two for me and see what solution you get. And if you're stuck on something, tell me, and I will help you out. Do you plot M or B first? B first. So plot your y-intercept on the vertical axis first, and then move from there or other value. Yeah, it is. All right, I'm going green and blue this time. Anyone think they have a solution? What's the format of a solution again? What should you be giving me? That would be the form of the equation, slope-intercept form.
Oh, okay.
What is a correct answer going to look like? It's an x and a y. It's a point, okay? So you should be giving me a point. It's where did this line meet that line? Okay, so let's take a look. What did you get as your solution? Anyone feeling confident in theirs? Yeah, it's a 9. You're so very close. You want to tell me?
-2.
-2, 8. which I'm guessing is probably either you switched your slope or you just named the point wrong when you were done. We'll see. Okay, so you have, for the green line here, up 9, right? Your first thing you plot is up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and now your slope, your M, is 1/2. So I'm going to go up 1 and to the right 2. So up 1, right 2 puts me here. Because I like extra points, I'm going to go the other way because there's not room to go up top. So now I'm going to go down 1, left 2, just to keep it going for a little bit. Did you get that for your first line? Yeah? Okay. Now I'm going to switch to blue. What do I plot first in my blue equation? 6. So that's my y-intercept. I'm going to go 1, 2, 3, 4, 5, 6. What is my slope of that line? -1. If there's a negative there, that's a -1 for your slope. So -1 means you go down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. But look if we go the opposite way. We hit at exactly that point. That's your answer. That's your solution. Okay? So -2, 8 is your answer. All right? Questions on that? Okay. Moving right along. Let's go to number 4, because number 4 takes a little bit more work than previous ones did. Look at the 2 equations on number 4. Are they both in slope-intercept form? Remember, slope-intercept is y equals mx plus b. Okay? So this one is, the second one is, but the first one is not. So we'll ignore the first one for now. Let's plot the second one. Y equals -1/2 x plus 2. Where do you move first? Up 2. This is always your first move. Okay, so you're going to go up 2. You'll never go left and right there. Okay, y-intercept is always the vertical, so it's always going to be up or down. And then from there, now you can do your slope, which is a -1/2. Where do you move for a -1/2? Down 1 to the right 2. So down 1, right 2, down 1, right 2, down 1, right 2. Looks something like this. Okay. All right, I'm going to rewrite the other equation right here because we're going to mess with it a little bit. Now, you've probably learned how to graph in standard form before, and you are welcome to do that. Remember the cover-up method? Did Mr. Lieber call it the cover-up method? Okay, so you could do the cover-up method here, and you would say x equals 4 and 2y equals 4, and you would solve for both of them, and you would plot them as an x-intercept and a y-intercept. For right now, I'm just going to turn everything into slope-intercept. So if I want this to be in slope-intercept form, what's my first move? Remember, slope-intercept always has y by itself. So if I want to get y by itself, what do I have to do first? You have to subtract the x. Okay, so here's what I have right now. 2y equals, this is a -x and a +4. Okay, technically you could say 4 minus x, but then it's not in slope-intercept form, and then I think people get confused. So just keep your x out in front, so that's a -x. You have to do one more thing to get it in slope-intercept. What is it? Divide. You're going to divide by 2, and you have to divide everything by 2. Okay, so this is 1, which means it's y equals, so that's a good start. How can we write this differently? Not -2x, -1 over 2 times x, right? So my slope is a -1/2, and then it's times x, and then 4 divided by 2 is 2. So this is the line we're going to graph. Y equals -1/2 x plus 2. Where do I move? It is the same. We're going to move up 2 for my y-intercept. So up 2 puts me here. And then my slope is down 1 over 2, down 1 over 2, down 1 over 2. It is the exact same line. So what's my solution? Infinitely many. So you may write this, or you may write infinitely many, but that means any set of points is going to work here, okay? There's an infinite number of solutions to this problem because it just keeps going along that line. Any point on those lines will be a solution. Questions on that? Are we refocused? Brains turned on? We're so close. Okay, let's do... We're going to do number 5. Look at number 5 here. I'm going to do this one second. I'm going to start with this one because this one's a little different. It doesn't look like it's in slope-intercept form. Technically, it's in slope-intercept form. It just doesn't look like it, okay? Y equals, there's no x. So let's think about this. If it's y equals mx plus b, but there is no x, then the slope, to get rid of an x, that m would have to be what number? What can you multiply by to just get rid of things? Poof, they're gone. Not itself, 0. If I multiply something by 0, it's 0. And 0 goes away, right? It doesn't change anything in our problem. So that means your slope, when it looks like this, y equals a number, your slope is 0. Do you know what kind of line has a 0 slope? It's one of these. It's vertical or it's horizontal. Do you know which one? It's the horizontal. Okay, so here's what I always tell people. When it's y equals some number, if you take a y and you flip it over, what letter does it look like? An H. That's a horizontal line. Okay, so whenever it's y equals just a number, no more x, that's a horizontal line. So if y equals -7, on your y, go 1, 2, 3, 4, 5, 6, 7 down. Okay, my y value is 7 right there. Where else is there a point that has a y value of 7? How about 1 -7, or 2 -7, or 3 -7, or 4 -7? All of these points have a y value of -7. Okay, so when it's y equals a number, horizontal line. What do you suppose it is when it's x equals a number? That's a vertical line, okay? So if you come down here to number 8, when it's x equals -2, -2, 0, -2, 1, -2, 2, -2, 3, -2, 4, x equals is vertical. Okay, so just think about the point. If you name the point, your x value is a -2. Anywhere you go there, okay? Okay, come back up to number 5. Now you have this equation, x plus 3y equals -15, okay? If we want to put that into slope-intercept form, what do I do first? Before you divide by 3, we will eventually, not divide by x, subtract x, right? So that gets that out of there. We have 3y equals -x minus 15, and then we divide by 3. So divide by 3 everywhere, and we end up with y equals, because this is 1, this would be a -1/3 x, and this is -5. Okay, see if you can graph that. Y equals -1/3 x minus 5. -1/3 x minus 5. Okay, did it look like this? -5 goes 1, 2, 3, 4, 5, and then -1/3. So down 1 to the right 3, down 1 to the right 3. Does yours look like that?
Yes.
What's your solution? Remember, your point is always an x value and a y value. What's the intersection? What? Not 9. So starting here, 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6, 7. So 6 to the right is a +6. 7 down is a -7. Okay? Okay. I'm not going to make you graph this one right now because you've graphed a lot, but I will tell you that this one ends up looking like that. Those are not the right lines, but something like that. What's your solution?
Oh,
No solution, right? They never meet. So if they never meet, it is no solution. You may write it like that, or you may write it like this. But either way, if they never meet, there is no solution.